In this problem, we need to evaluate and find the exact value of the expression cosecant squared 75 degrees minus tangent squared of 15 degrees. So how I'm going to go about doing this, and there's a couple of different ways to do this, but what I'm going to do is I'm going to say, first of all, when I look at this, I see that cosecant squared is of 75 degrees, tangent squared, this is 15 degrees. These angles don't match up. So in order to make them match up, what I'm going to do is I'm going to say, well, what do I know? I know that cosecant squared of an angle is the same thing as the secant squared of its complement, which the complement of 75 degrees is 15 degrees. So secant squared of 75 degrees, same thing as secant squared of 15 degrees. And then I'll just bring down the tangent squared of 15 degrees. So now our angles agree. At this point, what I can do is I can say that secant squared of 15 degrees is 1 plus tangent squared of 15 degrees. And then I'll just bring down the minus tangent squared of 15 degrees. And therefore, those tangent squares cancel out because there's 1 plus and 1 minus. So what do we have in the end? Just 1. And that's my final answer. Now let's take a look at number 4. In number 4, I have the cosine of 5 degrees times the sine of 85 degrees plus the sine of 5 degrees times the cosine of 85 degrees. So I can rewrite this as the sine, because we have the sine and cosine mixed together. So that's the sine of a plus b. And my a is 85 degrees and my b is 5 degrees. Or vice versa, it doesn't really matter. So this turns out to be the sine of 90 degrees, which is 1. Final answer. Now that didn't use the complement rule. And so if I had wanted to do it that way, I could by saying the cosine of 5 degrees is the same thing as the sine of the complement of 5 degrees, which is 85 degrees. So then I have sine of 85 degrees times the sine of 85 degrees plus. And then I could say, well, sine of 5 degrees, that's the same thing as the cosine of 85 degrees. And why am I changing it all to 85 degrees? Just happen to like to do it that way. So again, there's other options, other ways to do this. So now what I have is the sine squared of 85 degrees plus the cosine squared of 85 degrees, which again is just 1. So a couple of different ways to do that problem. In this problem, we have a baseball diamond, and that is a square with first base, second base, third base, and home. And here's center field. And we know that the distance from home to first base is 90 feet, and from home to center field is 409 feet. So we need to find the distance from first base to center field. So we need to solve this triangle. So what do I know about this triangle first of all? Well, what I can see, I have this side, and I also know what this angle is. Well, how do I know that? Since home is going straight out to center field, because it did say dead center field, so what we mean by that is it's straight out from the home plate through second base. And so since our line is going through second base, that means this must be a 45-degree angle. So now I have an angle and the two sides on either side of that angle, and so we can solve for x and get our solution here. So I'm going to use the law of cosines to solve this because we have side, angle, side, and that's a law of cosines type problem. So x squared is equal to 90 squared plus 409 squared minus 2 times 90 times 409 times the cosine of the angle that's opposite side x, which is our 45-degree angle. And so when I put this all into the calculator, I get 123,323.7988. But remember, we want to find x, so I take the square root of that, and personally what I do is I just hit, after this is displaying, I hit the caret and 0.5 and just raise to the 0.5 power rather than trying to take the square root with the radical symbol. It's just a little quicker, a little less button pushing. And I get 351.17. It's set to round to 2 decimal places? To 1 decimal place. Okay. Well, 351.2. There you go. So that's how we get that answer. In this problem, we need to find the angle theta formed by the diagonal of the 2 by 3 inch side and the diagonal of the 3 by 4 inch side of this box. So how I'm going to go about doing that is, first of all, let's find the length of just that diagonal of the 2 inch by 3 inch rectangle. So since this is a right triangle that I have going here, right, coming along here, then what I'm really looking for is the hypotenuse of that right triangle. So I'm just going to say, 2 squared plus 3 squared is 4 plus 9, which is 13. So what is that length? The length 1, is the square root of 13. Okay. So I've got square root of 13. Next, I'll find the length of the diagonal for the 3 by 4 inch side. And again, that's the hypotenuse of a right triangle. So what I have is 3 squared plus 4 squared, and that's 9 plus 16, which is 25. So that length, length 2, is 5, square root of 25. There you go. Okay, so now I have these two lengths. Now this is actually ultimately going to form a triangle. And so where is my third side? Well, my third side has to join the other two endpoints of the other two sides. So here we go. We've got our third side, and that's completing the triangle. And so this length is actually lying along the diagonal of the rectangle that is 2 inches by 4 inches. So again, it's the hypotenuse, and I can find that length. So then we have length 3 is the square root of 20, or 2 times the square root of 5. So now I have a triangle, and I have the length of each of the three sides. And so of course we can find angle theta from this, and I know that the side that we just found, the one that's in green, that has length 2 times the square root of 5. That is opposite of the angle theta that we're looking for. So when I use my law of cosines to solve this, because I have three sides, so I'm going to solve for theta using law of cosines. So what I will do is say that that opposite side, and I'm going to go back to calling it square root of 20, because what am I going to do right now? I'm going to square it. So I'll just say square root of 20 squared equals, and then I'll take 5 and square it, plus the square root of 13 squared, minus 2 times 5 times the square root of 13 times the cosine of theta. So now I only have one unknown in this formula, and I can solve for theta. So square root of 20 squared, that gives me 20. 5 squared is 25. Square root of 13 squared is 13. Minus, and then we have 2 times 5, which is 10, times the square root of 13, times the cosine of theta. Now here's where students often make a mistake, and it's just kind of everybody wants to do this, and you just have to be really careful not to do it. Now the 25 and the 13, those can combine together. Those are like terms. This is not a like term. You can't just do all of this together and then say that's the coefficient of cosine theta. This is not multiplied by cosine theta. This is not multiplied by cosine theta. So what I'm going to do is say 20 equals 25 and 13 is 38 minus 10 square root of 13 times cosine theta. And now I'll subtract the 38 from both sides. And I'm really going through the basic algebra here, but it is something where people tend to make errors that they really know better, but just a lot going on. So we have negative 18 equals negative 10 times the square root of 13 times cosine theta. So to solve for cosine theta, I'll divide both sides by negative 10 square root of 13. And that means that cosine theta equals negative 18 over negative 10 square root of 13. And, of course, those negatives cancel out. And I could do more simplifying. I'm not going to really worry too much about it because I really just want to know what theta is. So theta is then the cosine inverse of that expression. And I can just type it in just as we have here. And when I put this into the calculator, I'm going to end up with 60 degrees. And that's what you get. So it did say round to the nearest degree. So that's what you get for that. So just when you're taking the exam, just make sure that you round as directed in the directions. And that is the end of those problems.